So yes, as I said, welcome to Cal Poly Physics Open House. I'm delighted you could join us today. First of all, I hope that you're all doing well wherever you are, that you and your loved ones are well. We would have loved to have you join us in person and to be able to show you around our wonderful campus and have you meet our wonderful colleagues and students. But these are unusual times and we're going to do the best we can with a virtual form. So let me just first of all start by making some introductions. Joining me today, we have Kat Gillen, one of our professors. Kat, would you like to introduce yourself? Kat, I think you're muted. Oh.
Step one, we totally know what we're doing here. All right. Again, I'm Kat and I'm one of the professors here. And my research area is in atomic physics and quantum computing. And I'm also the advisor for our Women in Physics Club. And I'm also the faculty advisor for our international exchange programs with 2 partner universities in Germany, where students can study abroad for a quarter or a year. So ask me about those things. Thanks.
Thank you, Kat. Next, we have Dr. Matthew Melter, also one of our professors. Matt, over to you.
Hi, welcome to Cal Poly Virtual Open House. I'm a professor in the physics department and I specialize in condensed matter physics and in physics education research. So we're very excited about a few programs we have involving learning assistance and the use of studio classrooms for introductory physics teaching. So I'd love to hear what anybody has questions about that.
Thank you, Matt. Next we have Ryan Walter, another of our professors. Ryan.
Hi, everybody. My name is Ryan Walter. This is my 6th year at Cal Poly. My research is in fluid dynamics and physical oceanography. And as you can see in my background picture, that's actually the Cal Poly pier where I did all of my research. So I have active research programs that involve students in ocean observing technology, offshore wind energy, and looking at how physical processes drive coastal ecosystem changes. And so one of the things that I'm sure Karl will allude to is we have a large number of faculty doing a lot of really different research in our department. So looking forward to chatting with you all.
Thank you, Ryan. And next we have Kevin Coulomb, who wears many hats. He is a technician in our department, helps things run smoothly. He's a part-time instructor, and he's also a Cal Poly Physics alumnus. Kevin.
So again, thank you everybody for joining us in this unique and I'd say groundbreaking or revolutionary kind of open house. Yeah, so as Karl said, I've been part of Cal Poly Physics since my freshman year. I actually had a BA in physics, which is something that we do offer. And then I also minored in our astronomy program, was one of the first students to go through that. I then did research under one of our high energy particle physicists with the ALICE detector, one of the 4 main experiments at CERN at the Large Hadron Collider. And after all that, I came back and I do help with all the equipment in the department, setting up labs, doing repairs, and I even teach a couple of our introductory series courses when the need arises.
Thank you, Kevin. And we also have here Maddie Larkin, who is one of our student leaders and a graduating senior. Maddie.
Hi, I'm Maddie. I'm a graduating senior with a BS in physics. I have a minor in math, and I am the current president of the Society of Physics Students.
Thank you, Maddie. Well, oops. So I just wanted to share today's plan for how we're going to proceed. I'm going to start by giving a sort of a little slideshow here, telling you about our physics department, in particular about our curriculum, about the research opportunities that are available for our students, and also about our wonderful departmental community. After this presentation, which I hope will take approximately 20 minutes, we'll have a Q&A with me and with my co-panelists. So this will be an opportunity for you to send questions via the Q&A feature on your, you should be able to see that on Zoom. And we will try to answer those questions either live by me or one of the panelists speaking, or perhaps by directly messaging back via the Q&A channel to you with an answer to your question. So some of you may have questions, kind of just general questions about will there be virtual tours, other sort of more university level type questions. We have a link to some frequently asked questions of that type that our panelists may send back to you in response to such a question. If you feel that once you check that link or check that frequently asked question and you're not getting enough information, by all means, please get back to us so that we can give you the information we need, that you're looking for. I would also say that you may also have some kind of very particular questions about your own personal academic situation, whether a certain AP score allows you to sort of get credit for certain classes here, or whether a class you took at a junior college allows you to get transfer credit for a class. Normally, during a real open house, we love to sit down and get into the nuts and bolts of that sort of academic advising with you individually. Today is unfortunately not the best venue for that. So with such questions, our panelists can try to help, but I think that they may also ask you to just get in touch with physics@calpoly.edu so that I can then follow up with you over the week ahead and try to get you those answers to those more specific personal questions. The last thing I'll say is that during the presentation, we will have the Q&A open. So if you want to send questions to our panelists, they'll do their best to try to answer those questions in real time via the messaging feature. Okay, I think that was everything I wanted to say about the Q&As. So I think now we'll sort of move on with the actual presentation. Okay, so first of all, let me just say how excited I am for you and the big decision that you've got to make now. It's I think really great that you've been admitted to Cal Poly Physics. We're quite a selective institution, so congratulations on that. And also, I think congratulations on just getting to this point in life. It's a very, very exciting journey that lies ahead of you. So let me start by talking a little bit about our curriculum. So I think in everything that we do in our department, undergraduates are just the center of everything that we do. They are our focus. You are our focus. So in terms of our curriculum, this means that we have small classes. In our introductory physics classes, we usually have 36 to 48 students in those classes, compared, for example, to other larger universities, or rather other universities with larger classes, where you can sometimes be in an introductory class with anywhere between 300 and 500 students. So we really pride ourselves in our small class sizes. It really makes, I think, for a much more dynamic and interactive atmosphere within those classes. Our classes are all taught by faculty with PhDs. We do not have graduate students in our physics program, so none of our classes are taught by graduate students. We also have learning assistants, as Dr. Matt Melter referred to supplement our lower division classes, and indeed some of our upper division classes. These learning assistants are there to sort of provide peer-to-peer instruction within the classroom in addition to the professor. That way, if students have questions, the professor can try to help them, but learning assistants can also give them the answer to their question perhaps a little bit more quickly. I think one of the best things about learning assistants in our physics department is not just the help they provide students, but also the opportunity they provide for you, our future undergraduates, to become learning assistants and help other students too. So here we see a picture of Dr. Bob Echols in one of our smaller classes here. And here's Dr. Bob celebrating the joys of the electromagnetic tensor with his students. So the next picture I have here, in the upper left, we see one of our studio classrooms. So a studio classroom is a sort of a way for us to integrate what traditionally might have been separate lecture and lab sections. We can do them all together in real time within the studio classroom. So in this upper left-hand picture here, you see that there are desks. We have 6 students to each desk. And the students can work in groups of 3. They might be working on problem solving. They might be working on a short activity involving some equipment. And the beauty here is that as professors want to explain the concepts, they want to show the concepts physically, it can all be done in real time. In the lower right here, you see one of our learning assistants in the studio working with students, helping them. And as I said, I think sometimes the people who learn the absolute most through our learning assistant programs are the learning assistants themselves. I certainly find that by trying to teach or explain things, it really, really tests my understanding and helps my understanding to grow. So the next picture I wanted to show you is a shot from within our building where we have our physics department. This building you can see behind me in my background. This is, we call it the Baker Building, or Building 180. And our physics department primarily occupies the 2nd, 5th, and 6th floors. So here is a picture in the upper left of our 6th floor. Unfortunately, some of the pictures I'm showing here are devoid of people, because these pictures have been taken after we went into our shutdown. So usually this upper left picture would be teeming with students and faculty. And here you can see our faculty office doors. You can see where the students have space to work. And most importantly, I've shown you where we have a whiteboard. So the whiteboards are where our faculty, our students all get together. We do office hours outside of the office. This way we can get more students involved. Of course, if students want to have private conversations with faculty, we can do that in more of a traditional office hour mode. But we prefer our sort of general office hours to be more collaborative. And these are wonderful spaces for students to collaborate with faculty, working on problems, working together to just improve their learning. In the lower right-hand picture you see here is our student lounge for physics majors. Again, this would usually be bustling with students, usually working on upper division classes, perhaps taking a nap on the couch, talking about the latest social events that are going to be coming up. And really, this also, you can see we have a balcony on this student lounge. And this balcony, I think, provides one of the best views of campus. And we often have some students hang out there thinking deeply about the mysteries of the universe. So we pride ourselves in our department, and our university. We are a learn by doing university. We really pride ourselves on how lab rich our courses are. We have specialized labs in electronics, optics, quantum physics, solid state physics, nuclear and atomic physics, observational astronomy, and physical oceanography. So here we have a picture in the upper left of our electronics lab. This is where we teach our Physics 206 course. And here we would have 12 students in this laboratory, each at these individual stations. Here they would be working on projects from electronics. So we make sure that our students can have access to this laboratory outside of class time. So they have key cards that can swipe in and they can work on their projects outside of classroom, or sorry, outside of regular class time. In the lower right, you see we see our optics lab. This is where we have our classes Physics 323 and Physics 423, optics and advanced optics. And here you see there are 4 stations, each which has a sort of an optical table on which usually an array of lenses and other sort of optics equipment would be set up. And then in this lab, we would typically have between 8 and 12 students, and we would divide them up between these 4 stations. So we also, in the upper left here, you'll see our student makerspace, where we have 3D laser printers, we have a laser cutter, we have CNC machines. So this is where students can come in and use these facilities as either part of their classwork or, as we'll see, as part of their research projects as well. In the lower right, you see a picture of our observatory. So we have an observatory right here on campus, just below the Baker building that you see behind me. And this observatory is very active. We use it for Astronomy 444, which is our observational astronomy course. And this would be a good point for me to point out that I imagine some of you may have questions about minors. You heard that Maddie Larkin, one of our students here, is a math minor. Many of our students do an astronomy minor. So we have a very vibrant astronomy program. We don't have an astronomy degree per se, but we have about half a dozen astronomy classes. We have about half a dozen astronomy professors, all of whom are very active in research. That research can take place right here at our Cal Poly Observatory, or as you'll see, further afield. So our astronomy minor is something we're very proud of, and a lot of students will get in conjunction with their physics major. So moving on to our research and why undergraduates are the focus of our research. So here, as I said, we only have undergraduate students. We don't have graduate students. So the students that are doing research here are undergraduates. They do authentic research in various areas. We have about, oops, jumping the gun there. We have about 40 faculty who are doing research projects, which just provides an incredible breadth and wealth of different types of research projects, ranging from astrophysics to optics to theoretical physics, materials physics, biophysics, sustainability, particle accelerators, physics education, research, and we often have numerous faculty each working on these different fields of physics. As I said, we have a very large number of faculty doing research, approximately 40. We typically have somewhere on the order of about 200 physics majors. So our small student faculty ratio means that all students that are interested in doing research can get to engage in research with our faculty. Many of our students start in their research activities with faculty as early as their first year. All students engage in some sort of research activity before they finish up at Cal Poly, because every Cal Poly student must complete a senior project. And this is done with a faculty member, usually in some sort of research area that they've already been working on. So in terms of some of the research that's going on here, I'm going to show you, I think, a sort of a fairly small sample. As I said, we've got about 40 faculty doing research projects. So here's just a small sample of the sort of research that we have going on here. Excuse me. For example, in Dr. Marlow's lab, Dr. Colleen Marlow's lab, she studies carbon nanotubes. And here in the on the lower left, we see Roger, who's controlling electrostatic gate on a carbon nanotube network. That's what CNT stands for, carbon nanotube. Here we see Marissa in the middle, making an image of a carbon nanotube. The nano, I think, implies that obviously it's quite small. So making an image is no, no easy feat. And this is Marissa doing so with an atomic force microscope. And on the right-hand side here, we see Erica changing a carbon nanotube device inside of a cryostat so that they can understand the temperature dependence of these things. We also here have Savannah and Marissa also making some measurements on the electrical properties of our carbon nanotube transistor devices. And this is all taking place within Building 180, as I said, the building that you see behind me in my background. Here we have some photos from Dr. Beekman's research. Dr. Beekman, I think, is a sort of quite the photographer, likes to go for the black and white effect here. So here we have Dr. Beekman's research involves the thermoelectric effect, which is basically a sort of an area of materials physics. Here on the left, we see Tom coding some computational models. In photo B here, we see Juan soldering connections from instrumentation to a cryostat. Here we have Roger weaving wires together to prepare them for insertion in the cryostat. And lastly, we have Dominic pouring liquid nitrogen into the cryostat. We also have, as I said, quite a lot of astrophysics and astronomy research going on here. Here we have Dr. Edwards, who's a specialist in galactic formation and evolution. And this is her student Priscilla sharing some of her research results with Dr. Edwards. We also have Dr. Nathan Heston, who also works in materials physics, in particular with bimetallic shells. And here we have his student Maureen adjusting a thermocouple while making deflection measurements on that bimetallic shell. Here we have some of the research that takes place off of campus. So Dr. Bennett is one of our observational astronomers. She does observational astronomy with particular interest in understanding black holes and galaxies. And here you can see some of her students who have traveled to the Lick Observatory, which is in the Bay Area. And here they've done work with a 1-meter telescope and with a 3-meter telescope. So many of our students do travel off campus to do research with our professors at different facilities. But what's really wonderful in this sort of age of internet connectivity, as we're seeing right now, is also that Dr. Bennett can then connect to these telescopes. The students can connect to the telescopes, and after appropriate training, they can actually do observations from Cal Poly. So from the top floor of the Baker building, we have a room in which our students can connect to telescopes and do observations during the academic year. This means that they don't have to leave campus, they don't have to miss classes, they can do it in real time during the academic year. It does, of course, require some late nights and perhaps some sleeping in the morning. Our researchers go even further afield than Santa Clara. Dr. Heston took some of our students to Ghana this summer, where they built a solar-powered ice production facility and a community water tower. In the lower right here, you can see Tom and Will wiring energy panels to battery-powered freezers for some rural Ghanaian fishermen. So yes, Dr. Heston, both materials physics and sustainable technology. And then several of our students, or rather several of our faculty and their students, work on particle accelerator research. And 3 of our faculty have students that travel to Europe most summers including here Dr. Themis Mastoridis. He's in the top left-hand picture here. He is second from the left. He's with Philippe, Devon, and Aaron. And this is in the CERN Control Center. As many of you know, CERN is the particle accelerator facility in Europe, in Geneva. And Dr. Mastoridis takes his students there most summers. And then down in the right here, you can see them inside an actual tunnel next to a beamline. This is the LINAC 4 tunnel at CERN. And those of you who are interested, this is the accelerator that produces protons for ultimate use in the Large Hadron Collider experiment. And as I said, a couple of our other faculty members, Dr. Gutierrez and Dr. Clay, also send their students to particle accelerators in Switzerland and also Italy. So moving, sort of continuing with the sort of the opportunities that are available for our undergraduates as researchers, they have an opportunity to do research during the academic year for either pay. This would be being paid by a faculty member who has an external grant, as many of our faculty members do, or doing this research for credit, either lower division credit or upper division credit. In fact, the upper division credit counts towards the elective requirements. Students mainly do research during the summer. We have a very robust summer program. It's called the Frost Summer Program. And students can receive a $3,500 award for participating in this 8-week program, or they can get paid directly from faculty through those faculty grants. And over the last 2 years of the program, while I've been chair, we've had on the order of 80 physics students on campus doing research as part of this Frost Summer Research Program. It's really a wonderful experience where students not only get to do the research, but we have programmatic events like ice cream socials, barbecues. We also have seminars, both seminars on scientific topics, but also on career preparation, making CVs, understanding and learning more about what sort of opportunities there are available after graduation from Cal Poly. Our students present their work at conferences right here on campus, regionally within California, nationally, and even internationally. And they also publish their work in peer-reviewed journals. And generally, I think that the research just offers students another opportunity to just develop the skills, the resume that they need for graduate school, working in industry, or just generally following their dreams. So here we have some photos here from our recent Frost Summer Research Symposium, where we had students present posters. We also had a session in which students gave talks on their research. We had a lunch, you can see at the bottom here. And this is a kind of a good sampling of the students that were all on campus doing research last summer. The Frost Symposium is just a really wonderful way for us to celebrate all of the great work that our students have done over the summer, and also just to see the incredible diversity of the different sort of topics that they work on. The next picture here was during our Frost Summer Program, where we see Dylan Tucker here, who's one of our physics alumni. And he works within industry, and he came to chat to our current physics majors about opportunities within industry. Here we have some presentations a little further afield. In the upper left-hand corner, these are actually two of my research students. I should have mentioned that my research interest is in liquid crystals. I do theoretical analysis of liquid crystal phases, just of the sort that appear in your LCD or liquid crystal displays. And here we have John and Edgar at an international liquid crystals conference presenting a poster to some experts in that field. In the lower right here, we see Marissa from Dr. Marlow's group. Marissa traveled all the way to New Zealand to present her research a couple of years ago. And this was at a conference, and I should say both pictures here were at conferences at which these Cal Poly students were actually some of the only undergraduate students at the conference. And all the more impressive, therefore, that Marissa, during her presentation at the conference, won an award for best poster for her presentation. And here we have Dr. Edwards and her group, and they are here at the American Astronomical Society meeting in Hawaii, where they also made presentations of their work. So we really, I think, love sending our students off to these conferences. I should point out, very important, that the students get to travel to these conferences and are reimbursed, or rather we fund those that travel from within our department. So students have really a great opportunity to go and travel far and wide and show off what they've been doing. So let me sort of wrap up the sort of three pillars of our department: curriculum, research, and departmental community. So we really strive and I think achieve our goal to support our students from day one until the day that they graduate. We have academic advisors here to help you. So these are professors, and you will be assigned to an academic advisor when you come here, and they can help you plan for the sort of classes that you are planning to take. They can talk to you about whether certain credit from other institutions transfers. They can help you sort of try to map out a course through our curriculum that best serves your interests. And they can also step in to help you if you're struggling a little bit. The transition to university is not a trivial one. And sometimes it takes a little while to get used to the new expectations in terms of studying. And our academic advisors are really great, I think, as coaches as well. Our professors are just very caring individuals. As I said, we have a large number of professors, 40, a large number of students, but still a very small student to professor ratio. So our students and our professors all know each other. Our professors look out for our students, both within their classes and in their research. Our front office folk, Michaeli and Michelle, are wonderful. They are there to help you navigate through some of the bureaucracy, whether that be forms, whether that be getting reimbursement for the trip you went to for that conference, or whether that be just needing to satisfy a candy urge that you have just to get you through that next class. And then we also try to really foster connections amongst our students right from day one. We get our physics students into classes together so that they are in there together, not with a whole bunch of other engineers, but we like to start getting those connections together amongst our physics students. We have a first year experience seminar that actually our technician, Kevin Coolham, has helped with, where we tried to get physics students together just as part of a seminar, just learning about what physics looks like, what it means to be a physicist, doing social things like bowling, doing fun experiments like trying to pop balloons using blow shooters with spaghetti, really fun things, but mainly, like I said, building connections. And then we also have a wonderful neutron-neutrino mentoring program. I'm sure many of you know that neutrons are bigger particles, neutrinos are smaller particles. So this corresponds to us as having upper division mentors helping mentor our lower division or incoming freshmen and transfer students. So here are some photos. Oh, sorry, not yet. I wanted to also just mention our wonderful student club life here. We have a student community. They host events with professors throughout the year. We have cook-offs, picnics, a spring banquet, outreach to local schools. And our clubs within the department are our Society of Physics Students Club, our Women in Physics Students Club, our Minorities in Physics Student Club, and our Astronomy Club. So here we see one of our students as Zek, who was doing some outreach with some third graders. Here he is showing a sort of a bicycle wheel gyroscope. This is certainly the sort of thing we would have loved to be able to show you here in person, but don't worry, once you get here, you'll be able to get in here and do hands-on fun physics demonstrations like this too. In our lower right, we have a cook-off at Dr. Matt Melter's house. We have various burn-offs, garlic-offs, all kinds of fun cook-offs at faculty members' houses. It's just a really great chance for students and faculty to all just get together and blow off a little steam during the quarter. Here we have photos from our annual fall picnic. This is really such a fun event. Usually we have over 100 students attending this, all of our faculty. We get together, eat good food, play games. This is in our local Santa Rosa Park. One of the highlights of the year is our spring banquet. This is all student organized. So this is an annual banquet, usually attended by our graduating seniors. Here we get to celebrate all of their achievements. We have awards. Our professors come as well. And these photos were taken in the local Madonna Inn, which you may have heard of for its famous individualized hotel rooms and just a wonderful decor, and not to mention delicious cake. And then of course, it's all about getting to the end, which is graduation. So our graduation here, you can see some photos from a recent graduation. We have our students in the upper right, students with Dr. Gutierrez in the lower right. And then I guess, given that the first photo I started with was an electromagnetic tensor, maybe it's appropriate to have the last photo show Maxwell's equations carefully painted on the back of the students' graduation robes. So thank you for listening to me as I sort of try to showcase some of our wonderful department. I think now I'm going to just sort of step out of the slideshow mode. I just wanted to remind you of who our panelists are. We have myself, Dr. Kat Gillen, Dr. Matt Melter, Dr. Ryan Walter, and Kevin Coolum, as well as Maddie Larkin. Some of you may have heard some screaming and noise in the background here. I've got some 3 kids here who I asked to not be too rowdy, but hey, what can you do? All right, let me exit from the show here and we'll get started with our panel discussion. Okay, so I'm just going to try to get in here to Q&A. And I have not been watching all of the Q&A here, but perhaps our panelists, if any of you would like to chime in and speak to any of the things that you've been hearing in the Q&A, that would be great. So I will turn it over to our panelists. Kat, I see you're unmuted, so perhaps you've got something to tell us about.
Well, mostly I unmuted myself so that I wouldn't forget, but somebody asked about things like double majors. So that is pretty common to have physics majors, double major. In other fields, the most common one is mathematics, which we have a lot of overlap with because of the math classes our majors take. So that's the most common one, but I've also had in my own research group, I've had several engineering students that have done a double major between physics and engineering, though they will usually take our Bachelor of Arts, our BA program instead of the BS, because it has a lot more free elective units, so then you can fill that in, like double count your engineering classes or whichever other major you want to do with that. We also have minors, so that's a little less work, but still gets noted on your degree. So we have several minors within physics, and people have also done music minors, so things that are a little further out. So those are all possibilities that you have. Karl, now you are muted.
Oh, classic. All right. Learn by doing. Yes. So yeah, and also I will say that probably our most common 2 minors are the math minor and the astronomy minor. And one thing that helps in terms of those 2 minors in particular is that there's a lot of double counting that you can do. So you're not having to take extra classes on top of those classes you're already taking within the physics major. Similarly for the math major, some of our students, as Kat mentioned, do double major, particularly in math. And again, that's because there's less sort of new classes that you would have to take. So Kat, I just noticed in the chat there is a question about, are there opportunities to study abroad?
Mm-hmm. Yeah, so we have several opportunities that are specifically suited for physics majors, which are with 2 universities in Germany, in Munich and in Bonn in Germany. And so there we have a list of classes that you can take there that would count towards your major here to maximize your course credit as you're going abroad. There are a large variety of other study abroad programs all over the world that you can take, but for those you will usually tend to take your general education GE classes to bring back to Cal Poly because they're not as well suited to the physics program specifically.
Thank you, Kat. Let's see, any other questions here? Let's see, I see a question here. How are you managing the continuity of research with campus and labs partial or to complete closure due to COVID-19? Great question. So the one thing I will say is that as far as our labs go, so let me just back up a little bit. So we received sort of, once the shutdown and shelter in place orders started coming in was at the end of our winter quarter. As you may know that we are on a quarter system here, 3 quarters as opposed to 2 semesters. So when the shutdown happened, our faculty just did an incredible job in terms of transitioning to trying to prepare their classes for virtual instruction in spring, and also to try to prepare some of our upper division laboratories. So while of course we would have loved to actually have in-person upper division laboratory experience here on campus, we're very proud of the fact that we did not have to cancel a single upper division laboratory, so our students can all move forward with their graduation plans. We are currently trying to figure out what we're going to do for summer. We're working in conjunction with the college. Our hope is that our Frost summer program can continue virtually. For some sorts of research projects, that'll be a little bit easier than others. For example, theoretical projects, computational projects. But we have such an innovative faculty, and I know that they're already thinking about how they can try to get their more hands-on projects converted to some sort of virtual format and some sort of format that's safe to happen over the summer. So we are hopeful that our virtual research program will continue over the summer. And then we're hopeful that by the time fall rolls around, we'll be back here in person.
Hey, Karl, I wanted to add one thing to that. I think the question was, in addition, also focused on research activities in addition to course labs. And so I will say that, personally with my lab, I do a lot of data analysis. And so I am still meeting with, 7 undergraduates every single week via virtual Zoom right now. So we're doing sharing screen. They can send me their codes, send me figures. And so we'll have a conversation virtually every week right now. And then also sort of, in line with a lot of the local and state guidelines, we are limiting non-essential research on campus. So, some of the hands-on lab activities that would normally be going on right now have ceased, at least until this COVID-19 goes away. But then we still have some activities ongoing. Like I have a couple projects that are, public health type related projects that I've gotten research appeals through the university to continue those activities, mainly with myself and some technicians I have. So hopefully that answers your question. So a lot of virtual research is still going on.
Kat.
Yeah, if I can add to that. So I have a atomic physics research lab. So it's a laser table in the lab with lasers, optics, all kinds of machinery. That's where I spend most of my time. But right now I still have 5 students working with me at the moment. And so some of them are working on some coding to run the lab equipment more automatically, and they can continue on that. I also have projects that are more computational, so modeling light fields and so on, and then very theoretical projects looking into quantum algorithms. So most of our folks have sort of multiple avenues of research, and so they will have plenty of things to do without having to step foot in that lab on campus.
Thank you, Kat. Yeah, I think that one of the great things is that while physicists often sort of, broadly sort of, I guess, distinguish between experimental physics and theoretical physics or computational physics, really all good physics has all components happening within it. And I think our faculty members sort of try to provide students with multiple sort of all those different sort of aspects of this research. And yes, while we can't be in person, we'll certainly be focusing on the sort of the non-in-person aspects that are more easy, like the computational side of things.
Oh, you got muted.
Sorry, maybe I got two. Third time I'm out. All right, so yeah, I wanted to come back to, there's another couple of questions I'm seeing here in the questioning. So one is sort of how flexible is the physics curriculum? And to what extent are we able to take classes that are not specifically physics related? So this reminds me that I wanted to point out that we actually have 2 programs within the physics department. We have the Bachelor of Science program. We also have the Bachelor of Arts program. Most of our majors are in the Bachelor of Science program. Now, in a sort of a weird quirk of our admissions system, we don't admit people directly to the Bachelor of Arts program. If someone wants to join the Bachelor of Arts program, they get admitted as a Bachelor of Science, but then we can very easily at the end of the first quarter switch them over to the BA program. Now, the distinction between the BA and the Bachelor of Science program is that the Bachelor of Science is a sort of a very technical, sort of rigorous curriculum, whereas the Bachelor of Arts has a little bit more flexibility involved. So in the Bachelor of Arts program, they don't have to take as many required courses as one has to take within the Bachelor of Science program. This means that it opens up the students' curriculum to taking other courses. For example, if students are particularly interested in geophysics, they may want to sort of do a Bachelor of Arts in Physics so that they can then get a geology minor with sort of emphasis on geophysics. Similarly, we've had some students who are perhaps interested in sort of, growing analytically and as a critical thinker by taking a physics or getting a physics degree, but are perhaps interested in applying this within the world of financial modeling. So such students may do a BA while getting the sort of the core of physics, and then also allowing them the flexibility to take classes in finance or economics. So yes, we do have a lot of flexibility. And if you are interested in having even more flexibility, I would encourage you to come talk to me about the BA program in more detail.
Maddie, do you want to talk about what some of our graduates do after graduation besides graduate school?
Yeah, I would love to. So as a graduating senior, I luckily have a job next year in the aerospace defense industry. So during my years at Cal Poly, I mostly participated in research, mostly like academic, and planned on going to grad school. I did theoretical research, I did experimental research, many different fields, and then last second applied for a job, got it, and doing that. So you can definitely focus on more physics during your whole career at Cal Poly and then still go into the engineering field afterwards and don't have to go to grad school. Also, outside of engineering field, there's a lot of people go into data science. Medical physics is a newer field that's really popular. I know some people who go into medical school or go into law, and then what Dr. Saunders said about going into finance as well. So there's a lot of different fields outside of going to grad school that you can get with a physics major.
Thanks, Maddie. Yeah, I think so typically about a third of our students go on to graduate school. Our students go on to graduate schools like UCLA, UC Berkeley, UC Santa Barbara, University of Oregon, University of Colorado at Boulder, University of Wisconsin, USC, UC Davis. These are some of the graduate schools that are springing to mind. One of our students also, recent students, was admitted to Caltech, and we're very proud about that. Another third of our students go into what we call industry, kind of like Maddie. And then about a sixth of our students go into some sort of a teaching role, so some sort of K through 12 teaching role. And the other six are just a sort of a wonderful sort of, smorgasbord of different careers ranging from finance to patent law and other things like that. For those of you who are interested in becoming teachers, I think a really great way to sort of get started with that, or just to test your own interest, is by becoming a learning assistant within the department. It's a great way to sort of get to to see if that bug of trying to explain things to people, trying to help people, is something you're interested in. And then on campus, we do have a single subject physics preparation program as well that a lot of our students become involved in. And I should also give a shout out to our physics education research program. As Dr. Matt mentioned, he's involved in that. And this just sort of looks into sort of trying to understand how best we can teach and sort of explain physics to all people, ranging from K through 12 to our own students. I did notice there was one question about someone asking if there was a possibility to double major in physics and computer science. Unfortunately, computer science is a particularly impacted program right now, so they do not accept double majoring. If one was admitted to computer science, then certainly one could double major within physics. I see there's also a question about astrophysics research. We don't have any astrophysics experts per se here with us today, but we do have many folks doing astrophysics research within the department. So this astrophysics research can range from sort of, like I said, observational astronomy with big telescopes. It can also range to computational analysis of data received from sort of, distant quasars. So we have sort of astronomy going on, we have astrophysics going on, and it's definitely one of our more popular sort of, I guess, areas of physics because it's just such wonderful science. So panelists, I know you're keeping a close eye on the chat here. Is there anything else that I think that would be helpful for me to answer? Or are we?
I think there's been a lot of questions about APs and skipping intro classes and calculus. Yeah,
so as I said, I can sort of speak generally to that, which is that depending on your AP score, you may be able to skip our calculus-based physics classes. It gets a little bit tricky because we have, two sets of introductory physics classes. One set is algebra-based. That's the set that's taken by our life science majors, for example, biology students. We also have our calculus-based introductory series, which is taken by engineers and also by our physics majors. So one has to be a little bit careful because you may get credit or test out of one of the algebra-based physics classes, but that's actually not the one you need to take. So occasionally, yes, some of our students test out of our first or even our second in the 3 sequence of introductory physics. And then we work with them to figure out their best sort of path through the major with that credit. Many of our students are testing out of some of the earlier calculus-based classes. Again, either I or an academic advisor would sit down with those students and we can work that out. But if there are sort of more detailed specific questions like I got this score on this physics AP test, that's probably not the sort of stuff that we can answer here right now, although we would love to. And as I said, please email physics@calpoly.edu, and then I'll try to get back to you in the next week or two and to set up a chance to chat about those particular questions.
So, Karl?
Yeah.
So I just want to comment on the AP stuff, that regardless of whether you substitute specifically for a course, you will get credit for your AP exam, provided you get a sufficiently high score towards your overall graduation credits. And so what that means is that even if it doesn't substitute for a particular class, you could possibly graduate a little earlier and or have a much more open curriculum when you get to be a junior or senior and have spots in your schedule where you could take another elective or something like that. So we will definitely recognize and appreciate students who have the AP scores. It just won't necessarily satisfy a particular physics requirement.
Yeah, let me also follow up there. Thank you, Matt. I'd like to just follow up and let you know that the decision as to whether or not certain AP scores allow you to get credit for certain physics classes is actually not made within the physics department. This is all made at the registrar's office, and they work, and then they will be the ones who are telling you what credit counts for what. In certain cases, there may be a class that you might have taken at a junior college that isn't on the the official list of transferable credit, and then I would sit down with you, take a look at what happened in terms of the syllabus, the material, and then try to figure out if it would be appropriate to substitute that class for another one. I see that someone asked about being able, whether one can do a physics major and a minor or a major in a environmental science class. We have the environmental science, or another example would be the natural resources and earth sciences program. Those are run from the College of Agriculture. But funnily enough, the natural resources and earth science program has its offices and labs right next to our physics program. In fact, the 3 geologists that are part of the natural resources and earth sciences program are actually within the physics department. So we do have quite a few of our students that do minor within the geology program. And I think right now there's at least 2 students I know of that are interested in geophysics while also getting their physics major. So I see there's a question about how many students transfer into the engineering program. It varies. We Cal Poly is somewhat unusual in that you have to declare your major coming into Cal Poly. So we understand that as students spend a quarter or 2 or after their first year, they may realize that there's something else that they prefer to be involved in terms of a different program. So we have some students who transfer from physics into engineering. We have students that transfer from engineering into physics. It's kind of a sort of a flow back and forth. So yes, it's certainly common. I will say, however, that the computer science program in engineering and I believe the mechanical engineering program are not accepting change of majors, which is what we call that process. I see there's another question here which says, how are the courses for first-year students selected? So what will happen to those of you who are first-year students, you will be what we call block scheduled into certain classes, which is a really wonderful feature whereby you don't have to worry about trying to enroll in certain classes. The advisors figure out what classes you're ready to take, and you will be automatically enrolled in those classes. This also guarantees you a spot in those classes for your first 3 quarters. There may be some selectivity on your part as far as what GE classes you want to enroll in, but depending on what AP credit you're coming in with in terms of physics, math, chemistry, then you will be assigned into the appropriate physics, math, or chemistry classes within your first year. And this block scheduling is also a way for us to ensure that the physics classes that you're assigned into also have other physics majors within them, so that we can start building these connections right from the get-go. So if there are sort of special situations in which you're sort of not sure whether you're in the right physics class that's being sort of that you've been scheduled into, then you're always free to reach out to your academic advisor or to me, so we can double check and make sure that that class is appropriate for you. So yes, so in that basic answer to the question is that people select and schedule students into those classes based on the preparation they're coming into Cal Poly with. So we have no open questions. As an instructor, this always makes me nervous. It's not sure, is this because I'm doing such an amazing job explaining things, or because I've sent everyone to sleep? Hopefully the former. But we have another 5 minutes or so here scheduled. So if there are any remaining questions, now would be a great chance to ask them.
And just a reminder, there is a Q&A button on the bottom of your Zoom bar that you can type into the questions in case you haven't found that feature yet.
Thanks, Ryan.
I guess, I mean, I know one thing on a lot of parents' minds from running open houses the last couple of years are the types of companies, or, maybe everyone wants to go around really quickly and, just say the types of companies that their students have gotten jobs in over the last couple of years. So, me personally, I have a good mix of students go on and get their PhDs and going on to industries. I've had students go on to engineering firms, defense contractors, Spar War down in San Diego. I have a student that went into data science and is down doing sort of big data for life insurance policies of all things. And so what else? I've had students that go on to work at sort of, oceanographic private organizations like MBARI, the Monterey Aquarium Research Institute. So maybe folks want to mention some of theirs as well.
Sure, I will. In the last few years, students that I've worked with have gone on to get jobs with places like Northrop Grumman. Another student got a job with Intuit, the people that make TurboTax. And another student went on to law school and has since gotten his degree and is now a patent lawyer.
I should say that also some of our students, I've been here for about 15 years now, and some of the students I first encountered are now becoming professors at other institutions, which is really a wonderful sort of evolution. Let me just jump in here. There was a couple more questions that popped up here. So one just wanted me to clarify about the fact that one cannot transfer to computer science. Sorry, I meant to be clear on that. Computer science is a program within the engineering department. So it's either called computer engineering or computer science. So that's the same thing. There was also a question about
Karl, can I interrupt? It's not actually they're two separate programs. So we have computer science, and then we have computer engineering, which is made up out of classes from computer science and electrical engineering.
Okay. Thank you, Kat. All right. Learning things all the time. So yes, I guess I am not sure then about, I do know for computer science, it's not possible to transfer, but computer engineering, I'm not sure. So if whoever asked that question would like to reach out to me, I can try to follow up with a better answer to that. So someone just asked about our honors program. So yes, there is an honors program within the university. And I do know that several of our physics students are part of that. I'm not quite sure how admission into the honors program works. Again, please follow up with me on that. I'll be happy to look into that.
For the honors program,
thanks,
if you want to apply for it before Cal Poly, I know you can just go to the website. I'm pretty sure you have to write an essay or something to get you admitted. And then you can also apply within your first year at Cal Poly, and you have to write an essay, and then they'll get back to you on whether or not you've been admitted to the honors program. And speaking, there's a separate honors, there's an honors society at Cal Poly, Sigma Pi Sigma, that you can apply for your second year at Cal Poly. normally your second year at Cal Poly.
So I saw there was a question about how realistic is it, or sorry, how attainable is it to complete a sort of a biology, chemistry, humanities prerequisites for medical school in addition to completing the BS in physics? I'm not sure about the detailed answer to that question. Again, were one to instead do a BS, instead of doing a BS, do a BA in physics, then I think there would be a lot more flexibility to be able to do those other classes. And then you would still be doing the classes that the bio students are doing in terms of getting prepared for med school.
So Karl, I might speak on that BA a little bit, because I actually did the BA program at Cal Poly and was able to get a double minor. I minored in professional communications and astronomy. So we've said how the astronomy and physics overlap really well. So that worked pretty nicely, and I didn't have to take that many extra courses. But the communications minor, pretty much everything in there required separate course loads that I could not get dual credit for. And the BA program offered me all the freedom to do that within my 4-year stint. So I was able to get the BA in physics and both minors within my 4 years.
Still amazes me, Kevin. Well done. Yeah, I also saw there was a question about GE requirements at Cal Poly. Matt, would you mind saying a couple of words about that?
So the university has a GE program that requires you to take a variety of courses outside of the physics and math and engineering areas. Within each area, however, there's quite a wide variety of choice that you have. So for example, in the area of literature or something like that, you can take courses in English. In some areas, there's overlap between history and philosophy and social science, but all Cal Poly students take courses in the GE program, regardless of major: physics, engineering, history, and there's a wide variety of selection within each category. And some of those will be determined sort of when you first come in. Every student has to take a communications class, you have to take a writing class. But once you get into the second and third year, there's a much wider variety of choice that you have available. And those, there's a few classes that you will automatically satisfy by being a physics major. For example, the quantitative reasoning requirement, as well as the natural science requirement, will be satisfied automatically, but everybody else. The GE program just underwent a big revision, and it's a little bit more streamlined now than it used to be, and there's a wide variety of courses available.
Thanks, Matt. There was one more question about a student who is waitlisted and wondering how it might work in order to get off that waitlist or be admitted as a transfer student. So similar to the articulation of AP credit, the physics department itself does not control admissions. And this is all sort of controlled centrally by the university. So how that admission process works and what sort of numbers move off the waitlist is something I'm just frankly not sure about. So I'm sorry I can't give a better answer to that. But I can tell you that we do admit numerous transfer students every year. They come in their, into their sort of junior year as a physics major. And then we work with transfer students and sort of make sure that we can build and find a path to graduation, sort of depending on what sort of things they're coming in with from their junior college. So I'm not seeing any more questions. Again, I think some students, like I said, if you want to follow up with me about anything at all, please do so. I'm happy to either respond to you by email. I'm happy to set up a Zoom chat with you individually, if that's easier. You can reach out to me directly using my email. You can search for it at our department website. Let me also say as well that on our department website, if you haven't already checked it out, you can also see some of the research that's going on here. As I said, I was able to sort of show you a sort of a cross section of that research, but there's so much more going on. And it'd be really, I think, fun for you to check out our department website and see the different types of research and the different types of research that's being done with faculty. Sort of on that note, I will say that students take numerous approaches to doing research. Some students, like Marissa that I showed you earlier, she got involved in her research right from year one with Dr. Marlow and stuck with Dr. Marlow all 4 years. So she really got deep into that research in carbon nanotubes, as I said, so much so that she was able to go to New Zealand and win a poster prize for her presentation. Other students take a sort of a more of a buffet approach, which is really great as well, where students will sort of do research of one type over one summer, then switch over from astrophysics to liquid crystal physics, and then switch back over to biophysics in their third summer. And I think that's a really great way to kind of just explore all the things that are available and open, have different experiences with different professors. And really, I think, like I said, sort of both enjoy it, but also start thinking about what you might be interested in doing beyond Cal Poly. Well, everyone, I'd like to thank you all again for joining. I hope that you got to learn some things about our wonderful department. It's all about undergraduates. That is really and truly what we're all about. I really want to just thank our panelists again. Maybe we can just sort of roll through and have them say bye to you individually. Kat?
Hi, thank you all for coming, and just feel free to reach out with any questions you have that you think I might be able to answer. My email is kgillen@calpoly.edu. So hope to hear from you. Let me know.
Thanks, Kat. Matt?
Well, we really hope you do come to Cal Poly, but regardless of where you go, good luck with your decision and good luck in the future.
Ryan?
Yeah, thank you everybody for your time. I also really want to echo what Karl said about this is all about the undergraduates. I think what sets Cal Poly apart from other universities is that, we don't have graduate students in the physics department here. All of our research is with undergraduates. All of our teaching is with undergraduates. We don't have graduate students doing the teaching. And, we still have a lot of, sort of big physics programs here at Cal Poly where, I still have collaborators at big physics universities. A lot of my colleagues here in the department do as well. So we still get the best of both worlds here at Cal Poly, and the focus is really going to be on all of you, the undergraduates.
Well said, Ryan. Thank you. Kevin?
Again, just echoing what you've heard, Cal Poly is a very unique atmosphere. It's a very positive place to be, and the experiences you get here are looked proudly upon by all the alumnus and all of future employers that you might get, as well as grad schools. There's no way to feel that coming to a place like Cal Poly wouldn't help prepare you for whatever pathway you take down the road. So hopefully we'll see you on campus and you'll enjoy your times here.
Thanks, Kevin. And Maddie?
Yeah, I just wanted to also echo everything that everyone's been saying. Cal Poly has been one of the best 4 years of my life. Gave me so many opportunities to get involved in 4 different research groups, be that little buffet student trying everything out, get involved in multiple different clubs, and create amazing relationships with all of my professors. They really care about the students and are open to talking to you about life, physics, anything, all above. So hope to see you. Well, I won't be here next year. Hope you come to Cal Poly.
Maddie, I'm sure you'll be coming back to keep us running things smoothly as you have done over the last 4 years. Well, thank you again to our panelists. Thank you all for joining us. And as I said, any questions you have, please follow up with us. And I hope that you all stay safe and well, and good luck with your decision. Bye.